good morning everyone. Welcome back to the operating system session. So today in our class we are going to discuss about of the concept of process synchronization. So in this concept we will discuss what do you mean by synchronization, why we need that process synchronization, and what are the problems will occur while synchronizing the two different processes, and so critical section, how we have to solve that problem. So the critical section problem. So we are going to discuss these concepts in today's session. So the main objectives of today's session is to present the concept of process synchronization, introduce critical section problem, where these solutions can be used to ensure the consistency of the shared data. So before going to discuss the process synchronization, we will discuss about of the concurrent processes. Concurrent processes means the parallel execution of the processes. I hope in last chapters we already know that what do you mean by process and how to achieve the performance by executing the different process concurrently. So the concurrent process means that the parallel execution of the one or more process at a time. So in any multi-programming requirement or in any environment, multi-programming environment, the process will execute concurrently or either competing process or cooperating processes. Competing, one another word for competing process is nothing but independent process. So either independent or cooperating processes. So here what are the responsibilities of the OS while executing the process in concurrent mode? So in competing process, the OS is responsible for careful allocation of the resources. Careful allocation of resources and proper isolation of processes from each other. Proper isolation means that here the process are executed in independent fashion. Independent fashion. So the another kind of the process we already know, cooperating process. The word itself has the meaning. The cooperating process is nothing but the processes are cooperated while in the execution. So how the processes are cooperated? For that, OS operating system is responsible to provide some protocols to share some resources and allow processes to interact with each other, sharing or communication. So how the processes are communicating together means by means of sharing or by means of communication. Communicating via messages. These are nothing but the processes are cooperate together while in the execution. So the competing processes are independent processes. These processes for the execution, they will compete for devices and other resources, either of the file, input, output, or different resources we have it in a computer. So these independent process, while in the execution, they will compete for resources. But the processes are unaware of one another. That is nothing but independent process. So example is independent process running on a computer. So this independent process has to exhibit the following properties. It should be deterministic because while in the execution, it has to start and stop the execution without any side effects, because the execution results, because the processes doesn't depend on any other process. They individually execute and finish the execution. So another property is reproducible, proceed at an arbitrary rate. So in certain fashion, these processes will be executed independently. It doesn't affect any other process execution. That's nothing but competing processes or independent process. So the another category of the process are cooperating processes. Here, in this cooperating process fashion, they will know each other. The process will know each other and they can share the resources via these processes can know how the processes can know each other, either by the communication or by the sharing the resources. And also this cooperating these processes means that the one process can affect the execution of other processes, right? So that means that the processes are cooperating together. Suppose for real-time example, if a teacher is assigned some homework, at that time, that homework can allow to do it in a team, that one member can do certain task and while finish the entire assignment, the second person also is cooperating to complete that assignment. So here these two students are processes and while executing means that the completion of the assignment. So the two persons are coordinate together and complete the assignment. So another example is transaction process in railways or airline or stocks. So here what this kind of the processes exhibit the properties, it will share the resources or information. How actually the processes are cooperated means by means of sharing the resources or some kind of information. How these processes are cooperated directly, it shares a logical address space, either that code and data. Address space means that in that address space we have that code and the corresponding data required to execute that code, right? So the process, cooperated process can either of the directly share a logical address space, the code and data both together to another process, or it can allow to share only data through how it is shared the data, either through the files or through the messages. So these are the different kinds of the cooperation between of the two processes in an operating system. So why we required cooperation? So without cooperation, because independent process or competing process can complete the execution, right? So why we required this cooperation between the process means that we require to speed up the execution so that we can improve the performance of the system. So how we can speed the system means that while in the execution or while a process read the next block while processing the current one and also divide the jobs into smaller pieces, and that smaller pieces can execute concurrently. So that concurrently means parallelly executing two or more processes are executed parallelly so that the speed up of the system will be increased. So, and moreover that the modularity, construct the systems in modular fashion. So, it also share the resources. So, we require the cooperation to share some resources and speed up the system and modularity. So, for this achievement, we require the process has to be cooperated. So, we learned till now the different kinds of the processes. Independent processes, cooperating processes. In the cooperating process, how the processes are cooperate each together. So, while in the cooperation, we require the synchronization between the process. So, let us see process synchronization. What do you mean by process synchronization? Why we need synchronization? How we have to provide the solution to the data inconsistency. Right? So, let us see the first process synchronization. It's nothing but coordination of execution of multiple processes in a multi-process system to ensure that the system can access the shared resources. To ensure that they can access the shared resources. So, we require the coordination between two or more processes in any multiprocessing environment to ensure they can share the resources in an efficient manner. So, while processes are executed concurrently, sometimes the higher priority process comes or some other process may be interrupted at any times while in the execution. This concurrent access to shared data may result in data inconsistency. Let us see some example. How data inconsistency is going to be happen when we are executing the processes concurrently. So, to avoid that inconsistency, data inconsistency, we need to maintain some synchronization mechanisms. Make sure that the orderly execution of the cooperating process can be executed in a system. So, here to show the data inconsistency, let us we take one of the important problem, famous problem, producer-consumer problem in an operating system. What this problem will talk about of that. So, here there are two processes, producer process and consumer process. These two processes are executed in a concurrent execution fashion. So, here the producer process, duty of the producer process is it will produce the items. It will produce the items, data or information that should be consumed by the consumer process. So, for example, if you take compiler may produce the assembly code which is consumed by the assembler. The assembler in turn produce the object modules which can be consumed by the loader. So, here compiler, assembler, loader. These are the three processes. Compiler will produce some code. It will use it by the assembler. Assembler will produce some code. It will use by the loader. Like this. So, here in the producer-consumer problem, producer will produce some items and consumer will consume some of the items. So, even otherwise, in a real-time example, if you take it off a store, so the producer is in the sense of that the storekeeper, that he will keep on produce the items and make the store is going to be full. Once the all items he is produced, then the consumer or customer is going to accumulate or is going to take away the items from the store. Once actually the particular product or particular item is going to be empty, then the again producer has to take in care to produce the items. This transaction, if you consider it, is a one buffer. Once actually the producer is trying to produce the item. So what here it has to be happen means while the producer are producing the items, at the time if you are not allowing the consumer to consume the items, if these two processes are executed in independent fashion, because producer is producing the items, producer is sending the item into the store. That time if you are not allowing the customers, then obviously there is no problem at all. There is no data inconsistencies. But with that, what will be happen? The inefficiency is going to be happen. So to make it of efficient use of that thing, so what we are going to do, even producer are producing by looking of the particular product or particular item is not there. Producer are producing the items and consumer, both processes are going to be executed in a concurrent fashion. So to allow the producer and consumer process to run concurrently, we have to maintain, we have some available buffer of items that can be filled by the producer and emptied by the consumer. This is a problem definition and how actually it is going to be happen. To implement of this, we are maintaining two logical pointers in and out. So initially what will be happen? In means that next, because we are using of input means that next free position in the buffer. And when in equal to out means that it is the storage or the particular buffer is empty. And if in this scenario in +1% buffer size, for this we are maintaining the buffer size equal to out, then it means that it is a full. Because if the products are producing items are full, then no need of again produce the items at that moment. So the code for the producer and consumer is like this. Initially when it is true, then we can enter into the code, producer code. And here we are maintaining the one shared variable counter. We are using of one shared variable. Means here counter is a shared variable. It is a shared resource because we always is saying that the two processes are executed concurrently and communicated via, and they can cooperate by sharing the resources. Here this variable is act as a shared variable, and while counter equal to buffer size means that, so it is full, then do nothing. The producer is not going to produce any items. So if it is less than buffer of in equal to next produce, suppose input means that some free slot is there. If you observe that, this we will implement with array. So in and out will be maintained. In and out are logical pointers, right? So buffer, this is a buffer array. Buffer of in equal to next produced item, because I have some space in my buffer. Till in equal to make it of entire items are going to be complete or store it to the buffer array. In equal to in plus, because suppose if I am producing one item, then very immediately in has to be increased to next. In has to move to the next pointer. So till up to what point you have to till in equal to in plus 1% buffer size, means till the completion of the buffer. So once actually you kept it of one item, then obviously what you have to do? You have to increment the variable counter plus plus. But then only you can able to make the while loop is going to complete the execution, right? So what to use when we are going to use the while loop, we have to give it up. One is initialization, condition, and then increment. So with these three, actually we can able to stop the execution of this producer, right? So here counter, when actually one item you are produced into the buffer, then you automatically has to increment the counter variable, right? This is the code for the producer, because by using of this, if you implement this in the system, so the producer able to produce the item in the buffer. So now let us see the consumer. Initially, when actually consumer will sit idle, when there are no items in the buffer, means that the counter equal to 0. So if counter equal to 0, then do nothing. The consumer won't do anything. He can't able to consume any items. And once actually next consumed equal to buffer of out. So he is taking out, we are using of some variable and we are taking away consuming the amount or consuming the item from the buffer by using of out variable. So now once you are consuming the item from the buffer array, then what you have to do? You have to decrement, you have to move the out variable to the less. So out equal to out plus 1% buffer size, and then you have to decrement the counter. If you observe there, while in the producer, what he is doing, that counter variable, he is incremented because he is producing the items. While in the consumer, he is decreasing the counter variable, but both are using the same variable, that is shared variable, counter. So counter minus, then consume the item in the next consumed. So in certain scenario, after some time, actually counter will become the 0. Then actually this while loop will be quit out. We can terminate or we can come out from this while loop by the consumer. So while we are implementing, we are saying that the counter variable is act as a shared variable. So the producer and consumer are using the same variable counter. So how actually, let us see how data inconsistency will be happen. The same counter variable, if you implement in a machine level language, so this counter could be implemented like this. So it will use some local CPU registers. So if you write for the counter, the assembly level language code or machine level language code for this, then how actually the code will be look like this. The register 1 equal to, because it will use the local CPU registers for the manipulations. Register 1 equal to counter, register 1 equal to register 1 plus 1, counter equal to register 1. These three statements will be written in assembly level language in a to implement of this counter plus plus variable. The same fashion, counter minus can be implemented as register 2 equal to counter, register 2 equal to register 2 minus 1, counter equal to register 2. Let us consider, initially we can take it off the buffer size or counter equal to 5. Counter equal to 5 means counter initially we can consider equal to 5. Means 5 buffers are full. So how actually the producer And because there are these two processes, producer and consumer process, are executed in a concurrent fashion, in a parallel fashion. And based on the order of the execution of these two processes, this is one of the scenario. This is one of the case. The transactions will be happen like this. And let us see what value will be coming out. So if you observe this transaction 0, because two processors are executing concurrently, parallelly. If producer is executing register 1, and what is the initial register count? Register 1 equal to counter. What value? The 5 will be stored into the register 1. Then again producer is executing register 1 equal to register. Up to these two statements, actually the producer is executing. So then the counter becomes 6. After that the consumer is, because producer is not executed this third statement, and while arbitrarily interleaving the order of the sequence of the execution of the statements, the consumer is coming up and consumer is accessing the register 2 equal to counter. So register 2, what is there in the register 2? Counter equal to 5. Register 2 is stored, the 5 value is stored into the register 2. Then the consumer will execute register 2 equal to register 2 minus 1. The 5 becomes 4. 5 becomes 4. Again now producer is taking it. Up to what point actually producer is executed? Producer is executing now, the last third statement only is left. Producer is executing counter equal to register 1. Counter equal to register 1, what value it is stored in the register 1? 6. So counter became 6. And then now again the third statement is still not yet executed by the consumer. Counter equal to register. Register 2, what register 2 value is having? 5. So at last producer execute, leave the counter value 6 and 4. Leave the counter value 6 and 4. But when it is executing, what value actually, suppose say, if you change the order of this S5 and S4, then the counter will be 6. If you make it of S4 and S5, the counter value become 4. Right? So in both the orders, we are getting counter is 1 times 6, 1 time counter is 4. But really what value I need to get it? Counter equal to 5. Because counter plus plus could be implemented, counter minus minus could be implemented, and both these two processes are executed in parallel, and it makes the shade variable in inconsistent state. One time we are getting 4, 6, one time we are getting 6. That is mean by data inconsistency. So here that problem we call it as racing problem. So racing problem is nothing but a situation where several processes access and manipulate the same data concurrently, and the outcome of the execution depends on particular order. Because see, in the before example, if I execute in S4 and S5 concurrently, then counter became 4. If I execute the order S5 and S4, then counter became 6. Right? Because I am getting for one variable two values, two different values in two different times. So here the execution depends on the particular order in which the access takes place. That situation we call it as racing problem. So it means, is it wanted situation or unwanted situation? So it's a unwanted. What we have to do? We have to eliminate that data inconsistency. For that, we have to maintain the process synchronization. We need to maintain process synchronization. So for this, process must be scheduled to avoid the inconsistencies caused by the concurrent access to the shared data. Right? Inconsistency in the data lead to what known as race condition. So to avoid that, we will move to the next concept to provide the synchronization between of the two processes. We are taking critical section. We are maintaining critical section. So in this critical section problem, let us we consider a system is having of n processes. These are all the processes are executed concurrently, P0 to Pn minus, and this each process has their segment of code called critical section. So here in critical section, once a process is inside that critical section code, here in this critical section code, what code we are going to keep it? The shared data or shared code we are going to keep inside the critical section place. And here, when the processes are executed concurrently and wants to access the shared data or shared code, it has the permission. It should require only one process is allowed to be inside the critical section area. So here, if you observe, process may be changing the common variables, updating the table, writing the file, etc. When one process is in critical section, no other process is allowed in its critical section. That is, no two processes are executed in their critical section at the same time. So this problem is to design a protocol to solve that process can use to cooperate. So while a process wants to access any shared data or shared code, it has to ask the permission to enter in its critical section. The section of code implementing this request is called as entry section. So to get the permission to enter into the critical section code, for that we require some entry permission or exit permission. So that we are going to call it as entry section. Entry critical section followed by exit. Once the process is entered into the inside the critical section and complete the process, and it has to come out, right? For that we have used exit section policy. So means that any process wants to use any shared data, that shared data and shared code will be keep it in the critical section place, and it has to ask the permission entry section. Once the permission, then it will go inside the critical section and execute the code or access the data. Suppose if it is a data, then followed by once it completes the activity, then it will come out by the exit section, and then again complete the other reminder section of the code. The reminder code is in the reminder section. So this is the structure of the one process, general structure of the process PI. Do entry section, critical section, exit section. So once if any process wants to enter into the critical section, it has to execute this entry section code and get the permission, and it will be go inside that critical section area and access the shared data and shared code, then complete the execution by enabling the exit section. So once it is come out from that critical section, it will execute the remainder section of the code. Right? So how actually this critical section problem has to be designed based on these properties. It has to follow mutual exclusion, progress, and bounded waiting. These three properties has to be satisfied by the each and every process once actually the process wants to enter into the critical section. So what do you mean by mutual exclusion? Means that one process is inside the critical section, no other process is going to be allowed into the critical section. See, if process P is executing in its critical section, then no other process can be executed in the critical section. That is nothing but mutual exclusion. So, progress means that if there is no process is in the critical section and here some of the processes wants to execute inside the critical section, then who will decide who has to go inside? Means that only those processes that are not executing in the remainder section, those can participate in the voting section. Then make allow the particular process is go inside the critical section. The selection cannot be postponed indefinitely. This is a very important point. So the selection should not, because see, some three processes are trying to wants to come and executing inside the critical section. Then who has to select the particular process is only allowed to be inside? Means that whatever process are not in the remainder section, those processes are allowed to be inside that and select one process. It doesn't mean that suppose one process I have given a chance to go inside, then the other two processes will be wait over there for that. We haven't decision is not going to be postponed indefinitely. The next chance that second process has to get it and allow inside the critical section and finish the critical section execution. So that's not, progress has to be happen. It's not like keep on only one process is allowed to be inside the critical section and execute. The other process all based on the order, it has to enter inside the critical section. The another property, bounded waiting, means there exists a bound on the number of times the other process are allowed to enter in the critical sections after a process has made a request to enter in the critical section, and before that request is granted, because waiting has to be bounded here, because all the process has to get a chance to enter into the critical section. So to solve the problems of data inconsistency, we will see some more examples in next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.